Okay, Unit 10, Objective 1, we're looking at plotting polar coordinates. This is going to be new for pretty much all of us. It's definitely something that I believe every single one of us can learn, but it might be a little weird at first. It's definitely a different realm because we are so used to plotting points in XY form, which is called a rectangular form, and we're actually going to be looking at a new type of point. Which means you need to make sure you are advocating for yourself, right? Reach out, ask, watch the extra practice video, do some extra problems. Honestly, check your homework, right? When the answer keys really get released, take a look at that homework, make note of the ones you missed, make sure you actually understand how they're done. And ask, just like you would if you were in class. Just doing it through an online forum. Okay? So, Unit 10, Objective 1, plotting polar coordinates. As I mentioned earlier, up until now we have only studied plotting points x, y in the rectangular coordinate system. So what you see modeled over here on the left. Okay, x represents the distance from the y-axis, so along the x-axis, right? So if this was like 2, 5, we'd go right 2 and then up 5. Excuse me. And y represents the distance from the x-axis or along the y-axis, right? And we've been doing this since elementary school or whenever it is we first learned to plot an XY coordinate. In this objective, we will be introduced to another coordinate system called the polar coordinate system. So what you see modeled here on the right. Here in polar, our ordered pair is r theta, and this locates the point P with respect to the pole, which you can see is in a rectangular coordinate system what we call the origin. But between the pole and the polar axis, which again you see noted here, which again in the rectangular coordinate we call that the x-axis. Polar is called the polar axis. R is the directed distance along the radial line. That's going to be pretty important here because you will see values for R, which always comes first in your polar coordinate. You'll see values of r that are positive and values of r that are negative, and whether you are positive or negative determines the direction that you will be moving. And then the value of r, so 2, 3, 5, whatever it happens to be, tells you how far to move in that direction. So again, your sign out front tells you the direction you will be moving. And again, I'll model this in a bit. And then the value, the numeric number, right, will show you the distance you move. And you're moving along a radial line, which is the theta, right? Which will always be the second value in your polar coordinate. It's the directed angle from the polar axis. So again, you see that modeled here. R theta is this point, just like xy would be the point if we were graphing in rectangular. R theta is the point. Theta is some measure, so pi over 4, pi over 6, pi over 3, 2 pi over 3, etc. Negative 3 pi over 4, whatever the angle is, you go that distance, just like we've been looking at for the last several units. So this angle here kind of looks like maybe a pi over 4. I don't know for sure, but kind of looks like a pi over 4. Okay? And then your r is the distance you move out along that line. So the radial line goes all the way through the pi over 4 angle, or whatever your angle happens to be. And then the r is how far you move out along that line. Okay? Now that angle for the record has that point for the record has other names that would land us in the exact same spot. So every point has quite a few other possible names, but we are going to focus in on 4 for each point. So let me put this. Every point has other possible names. And again, we're going to focus in on 4 in particular. R theta, which is the one that we see here. And then for the record, r and then theta plus or minus 2 pi would also be a potential name, right? Because think about that for a second. Whoops, theta plus or minus 2 pi. Plus or minus 2 pi. Because think about that for a second. If you were to have labeled this radial line here at being at pi over 4, If I added or subtracted 2 pi to pi over 4, what would that do to the angle? A little picture for that second. What is a 2 pi again? As an angle, that's a full rotation, right? So if this is at pi over 4, if I rotated a full 2 pi either direction, I would still end up in the same spot, and so I'd still be moving r. Remember, r is the distance you move out along that line. I'd still be moving r along the same essential radial line. Okay, so that would be another name. And then the two that are probably going to be the weirdest for us at first, and so I'm going to write these down, then I'll explain why they work, are negative r and theta minus pi, and negative r theta plus pi. Okay, the reason that these two work is this. I mentioned earlier that the sign out front of the r tells you which direction you're going to move. And again, I'm going to model this in a bit, but we want to be thinking about all of these ideas as we move forward. Your sign in front of the r tells you whether you are moving towards your angle or away from your angle. This angle here is pi over 4, right? Or that's about pi over 4. We approximated it. If my r was 4, that would tell me that I was moving a distance of 1, 2, 3, 4 along that pi over 4 angle, right? But notice there's always this other direction to your radial line. This is not pi over 4, but it's the extension of my radial line in the other direction. Because if my r was negative 4 instead of 4, 4 tells me to move along my pi over 4 line, negative 4 would tell me to move away from that angle, right, in the opposite direction. And so while this is still pi over 4 here, if this was negative 4 for my r, I would be going 1, 2, 3, 4 away from my angle, right? And so negative 4 pi over 4 would put me out here, would be moving away from the pi over 4 angle. Okay, so why these two angle names also give me the same coordinate point is this. Take a look at your angle first. If I subtracted or added pi to my original theta, remember my original theta was, we guessed, about pi over 4. If I added or subtracted pi to that pi over 4, what would happen to that angle if I added pi to it? Okay, well, pi is half a rotation, right? If I added or subtracted pi to my pi over 4, it would take this line and it would rotate it half a rotation so that the line was now down here, not at pi over 4, but at 5 pi over 4. Right? And so if my line was now down here because I've added or subtracted pi to it, and then I move a negative r, I'm moving in the opposite direction of that angle. That would mean I would be moving that way, right? Going negative r would still end up putting me at the same location. And again, you'll see this modeled in a bit. But these 4 names are going to be important to keep in mind because one of the things you will have to do within this objective is name, or give, I should say, give other coordinates that would still land you in the same location as the given polar coordinate. Okay? And so we'll come back and reference these in a bit. Okay, final thing here for graphing polar coordinates, and I've been referencing this a little bit in my explanation. Again, you're going to see it modeled shortly. When graphing polar coordinates, we start by graphing our radial line, right, which is this piece here, the rotation of your angle from your polar axis through the pole. And so you're graphing that angle the same way you have always graphed the angle. You're then going to move along your radial line r units, so 2, 3, 4, whatever the case may be, in the direction indicated by the sign of r. And so this is where that positive negative idea comes in, because if it's positive, so either towards, if it's positive, you are going to move towards your angle. And then if it's negative, you're going to move away from your angle in the opposite direction from your angle. And so the sign of r is going to determine which direction we move. And then the numeric value of r tells you how far to move. Okay? So we've got 4 examples here modeling graphing coordinate points. My recommendation would be to watch one, maybe two, but make sure you're trying a couple of these on your own. I'll still walk through the whole explanation, but pause the video, try it on your own, then rewatch the video. That way you're checking whether or not you're actually understanding what's happening. And if we get through all four of these and you get to number 4 and you still were like, I did not get number 4 right, then I would maybe recommend pausing the video. Don't go on to 5, 6, or 7 yet. Pause the video, go over to the extra practice video, do some more practice just with graphing polar coordinates, right? Make sure that you got that down before you move to 5, 6, and 7. Just like you would do in class, right? When we have extra time and we pull out whiteboards, or we say, do you want to do one more of these, or however it is that your class is run, when you have that opportunity in class to do another, take advantage for that for yourself at home. Pause the video, go to the extra practice, do an extra practice there, come back to 5, 6, and 7 when you're ready. Okay? Okay, so number 1 together here. We're graphing our given polar coordinates. We have 2 45 degrees is the polar coordinate we're trying to graph here. And remember, with polar, it's r theta. R always comes first, so my r is 2. My theta is my 45 degrees in this particular case. And so we're going to start by graphing our radial line. In this case, the 45 degrees. So where would 45 degrees land? Well, 45 degrees is in the first quadrant, about halfway. So we're looking at a radial line like that, okay? Because that's 45 degrees here. And then I always do the dotted line in the opposite direction, because sometimes if you have a negative r, you move away from your theta, right? Okay, so we've plotted our 45 degrees extended in the opposite direction. R then is how far you move, so we're going to be moving 2 along my radial line. And then if the r is positive, we're going to move in the direction of our theta, our 45 degrees. If this is a negative, we're going to move away from the 45 degrees. Okay, so in this case, this is a positive 2, so I'm moving in the direction of the 45 degrees, so I'm going to be sitting on this line. If it was negative 2, I'd sit somewhere on the dotted line, but I'm going to be sitting on this line. And in this case, I'm moving 2 along that line. So starting here, we have 1, 2. And so my coordinate point is right there. Okay? Okay, I'm going to do another one. Again, if you feel like you got it after just the one, great. Go ahead and pause the video. If you want to watch one more, that's fine. But again, on 3 and 4, I'd recommend pausing the video, trying them on your own. Okay? 2, plotting this coordinate point, we have r theta. So r theta. First up, graphing our radial line here. So pi over 6 is my theta. Where would pi over 6 be? Okay, well, pi over 6 is in the first quadrant. It's right about there. And then extending that in the opposite direction. Got our radial line. Okay, so r tells us how far to move. We're going to be moving 2. And then the sign in front of r tells us whether we're moving towards the angle or away from the angle. Okay, so in this case, my r is negative, so I'm not going to be sitting on my pi over 6 angle. I would have to have a positive to be sitting on the pi over 6. So I'm going to be sitting somewhere out here on the dotted line. The question, how far am I moving? Well, I'm moving 2 in this case. So we're moving 1 away, 2 away. And so that is my point. Sitting on the pi over 6 radial line, but 2 away from my angle as opposed to 2 towards my angle. 2 away from my angle. Okay? Okay, go ahead and pause the video. Give number 3 a shot. Restart it when you're ready to either check your answer or you're stuck and need to hear an explanation on number 3. Okay, we have our r theta. So first up, radial line. Where is negative pi over 5? Well, that would be in my 4th quadrant. And I don't actually know exactly what pi over 5 is, but I know what pi over 4 is. That's around the 45 degree angle, so halfway would be pi over 4. I know where pi over 6 is. That's the 30 degree angle, so that would be kind of in this realm. And so pi over 5 is somewhere between pi over 4 and pi over 6. It's It's a little bit of an approximation. I'm going to say it's kind of roughly speaking that. There's my negative pi over 5. And then extending that in the opposite direction. Okay, r for your radius then is positive, so I know I'm going to be moving along my radial line. In this case, I'm moving 4 along my radial line. So we're going out 1, 2, 3, 4. Okay. Okay, number 4, last one here. Go ahead and pause the video, give number 4 a shot, restart it when you either have an answer or are ready to hear an explanation. Okay, we've got our r theta. So first up, radial line, negative 100 degrees. So negative, I'm going reverse direction around my unit circle. Negative 90 would put me down here. So negative 100 is a little bit further than that. So we're looking at something along these lines. Again, a little bit of a rough approximation. I'm not exactly sure where 100 degrees in the negative direction would sit, but somewhere right around there. Okay, and then our r, so we're moving a distance of 5. In this case, our r is negative, so we're moving away from this radial line. So we're moving along the dotted line portion, away from the negative 100 degrees. And we're going to be moving 5 in that direction. So we have 1, 2, 3, 4, 5. There's my coordinate point. Okay. Okay, so that's plotting polar coordinates. Again, if you need to pause the video, go do some extra practice, come back and do 5, 6, and 7 after you feel like you're actually good with graphing polar coordinates. But it's very, like as you've seen, it's very similar to graphing x, y. Once you get the hang of it, they don't change a whole lot, right? Think about how comfortable you are graphing x, y coordinates now. You're going to get there with r theta as well. If you aren't there already, it just might, for some of us, mean taking a little bit of extra practice. So do that. If you do all the extra practice and you still need more, reach out. We are here to support you. Okay? But advocate for yourself. Okay? I, though, am now going to move on to numbers 5, 6, and 7. So again, pause the video if you need to. 5, 6, and 7, we're saying, okay, we've now looked at graphing coordinate points. Well, if I've got this given polar coordinate point, what are 3 other coordinates that would give me the same location, would land me in that same spot? And so this is where we're going to go back and we're going to reference what we talked about earlier, which is that there are always other names that land me in the same location. Okay? And we are going to, for the most part, I'd say, give our names between negative 2 pi and 2 pi here. So just knowing that up front. We have our 2, 3 pi over 4 as our first coordinate point. The question is, well, what are 3 other coordinates that would send me to the same location? And picture for a second, if you can, because it's a good thing to kind of practice, where would 2, 3 pi over 4 even sit? Because it's going to help you check your other coordinate points here. And maybe you even want to sketch it real quick, just a little sketch off to the side of where 2, 3 pi over 4 would be. Okay? Remember, 3 pi over 4 is your theta. So 3 pi over 4 is in the second quadrant. So there's my radial line. And then I'm moving 2. It's positive, so I'm going to be moving along that radial line towards the 3 pi over 4. And I don't have nice little circles here because it is my sketch. So let me go ahead and give a couple little circles. So we're moving 2 out, so we're looking at a coordinate point of about there. Okay, so what would be some other names? Well, first of all, we've got the fact that if I added or subtracted 2 pi to my theta, what I would have done is rotated this angle a full rotation, landing the angle in the same exact spot. And so moving r along that fully rotated angle would still land me in the same location, right? And so that's the first thing I'm going to do is say, okay, well, if I added or subtracted 2 pi to 3 pi over 4, where would that be? And obviously if I added 2 pi, that would send me up and over 2 pi because this is already positive. So I'm going to subtract 2 pi for this one. So 3 pi over 4 minus 2 pi. So what would this coordinate be? Well, it would be 2, 3 pi over 4 minus 2 pi, finding a common denominator here. This would be 3 pi over 4 minus 8 pi over 4, okay, which is negative 5 pi over 4. And so it's good to just double check. I'm saying that that's one of my other coordinate point names. Would that land me in the same location as what I've sketched? Well, pretend for a second you had to graph this radial line, negative 5 pi over 4. Where would that be? Well, negative pi would put me here. Negative 5 pi over 4 is that same radial line. And then I'm moving 2 towards that angle, so out 2 towards that negative 5 pi over 4. Sure enough, I land in the same location. Okay? Okay, the other two ones then are if we add or subtract, or I should say add and subtract pi to my theta, and then go negative r. Multiply my r by a negative. And so again, if I started, oops, a little space here. If I started with the same original r and same original theta, and let's start with subtracting pi, and then I took that r and multiplied it by a negative. Okay, so we're multiplying our r by a negative and subtracting pi. Okay, well, what would that give me? Multiplying 2 by a negative would give me negative 2. 3 pi over 4 minus pi. Common denominator would be 3 pi over 4 minus 4 pi over 4. Okay, which would be negative pi over 4. And again, double check it. Where would negative pi over 4 be if I graphed that radial line? Okay, well, negative pi over 4, let me do this in a different color. Actually, let me do a side-by-side graph, just to make sure there's no confusion here. Negative pi over 4 would be in the fourth quadrant, so there's my radial line, extended in the opposite direction. And then we're going negative 2, so I'm going away from negative, away from that radial line. So I'm not going to be down here on the radial line. I'm moving away from that over here. And 2 in that direction. Well, again, if I gave myself my little circles here, my little sketch, put me 2 in that direction, and notice I land in the same spot. I'm graphing that coordinate point. And then last one, negative r, theta plus pi. So I start with my r, multiply it by a negative, my theta, 3 pi over 4, plus pi, would give me negative times 2 is negative 2, 3 pi over 4 plus pi. Common denominator, 3 pi over 4 plus 4 pi over 4 is 7 pi over 4. Again, always good to just do a quick little double check. What would that look like if I graphed 7 pi over 4? That would be in the fourth quadrant, so that would be my radial line. Negative 2, so negative, moving away from that radial line. Opposite direction, 2, 1, 2, puts me in the same spot. Okay, so these are 3 other coordinate points that give me the same location as 2, 3 pi over 4. Okay, so we have 2 others. Again, my recommendation is either to pause the video now and try them on your own, or maybe watch number 6, but then pause the video and give number 7 a shot. But make sure you are checking. Are you actually understanding this? Because you're going to have to do it on your homework in a bit. And then if you are understanding after number 7, that's okay. That really is. Pause the video, go over to the extra practice video, do some of those, and come back when you're ready. Okay? So here we go. Number 6. We have 4 negative pi over 5. If the sketch is helpful for you, maybe you really quickly sketch that coordinate point so you can double check. But the first thing we need to do is figure out what is the first other coordinate point. Well, remember, if I started with the same radius, but I added or subtracted 2 pi to that angle, it would rotate my angle all the way around to exactly where it started. And so that would be my first coordinate point. Okay, so let's go ahead and take this and let's add 2 pi to it. Give it 1 full rotation. So this would be 4 negative pi over 5 plus 2 pi. Common denominator, this is negative pi over 5 plus 10 pi over 5, which is 9 pi over 5. And so I made my first one. And again, if you wanted to check it, so negative pi over 5 would be in the 4th quadrant, somewhere between negative pi over 4 and negative pi over 6. And we're going 4 out. So again, I don't have my little circles, but if you pretended we did, 1, 2, 3, 4. So my coordinate point would be out here, approximately. Okay, well 4 and 9 pi over 5, checking that. 9 pi over 5 would be all the way around, not quite to 10 pi over 5. 10 pi over 5 would be 2 pi. And so it'd be 1 pi over 5 short of 10 pi over 5. So we'd be on the same radial line, 4 out, 1, 2, 3, 4, lands in the same spot. Okay. Second one we have is a negative times our r, so negative times 4. And then our theta minus 5. I'm sorry, our theta minus pi. I said 5, but I meant pi. Okay, and so my r then would be negative 4. And this is negative pi over 5 minus pi, common denominator. Negative pi over 5 minus 5 pi over 5, which is negative 6 pi over 5. Okay, checking that for those who find the sketches helpful. Graphing our negative 6 pi over 5, negative 5 pi over 5 would put me here. Negative 5 pi over 5 is negative pi. And so negative 6 pi over 5 would be 1 more pi over 5 rotation in that direction. And then negative 4, so away from that angle, so we're going to be on the dotted line, 4 out. So 1, 2, 3, 4, we're looking at right there, which is in the same location. And last but not least, we have negative times our r, so our r was 4 times a negative, and then theta plus pi. Okay, well negative times 4 is negative 4. Negative pi over 5 plus pi is negative pi over 5 plus 5 pi over 5, which is 4 pi over 5. And again, double checking that one. 4 pi over 5 radial line would put me not quite to 5 pi over 5. That would be a full pi rotation. So 4 pi over 5 is 1 pi over 5 less than that. It's right there. And then negative 4, so away from that angle, 4 out, 1, 2, 3, 4. We land in the same spot as our other 3 angles. Okay, last one here. Go ahead and pause the video, give number 7 a shot, restart it when you are ready. And then again, if you finish number 7, need to do extra, then go do some extra practice and then come back when you're ready. Okay. Okay, number 7, we have negative pi, negative 2 pi over 3. So that would be negative 2 pi over 3 is rotating clockwise around our unit circle. And negative 2 pi over 3 would be the 60-degree angle in our 3rd quadrant here. Extending that in the other direction. And then we are moving negative, so away from that angle. So we're going to be landing here on the dotted line in the 1st quadrant. And 5 in that direction. So we're looking at 1, 2, 3, 4, 5. So my angle would be around there. Okay. Okay, so first up we have our same r, but our theta either adding 2 pi to it or subtracting 2 pi. Here we're going to add 2 pi because subtracting 2 pi would put me less than 2 pi. This is already negative. So I'm going to add 2 pi to it. So my r is still negative 5. Negative 2 pi over 3 plus 2 pi is negative 2 pi over 3 plus 6 pi over 3, common denominator. which is 4 pi over 3. Okay. Checking that coordinate point, 4 pi over 3 rotation, puts us in the third quadrant. -5, opposite from that angle, 5 out, same coordinate point. Okay. Next up, we have -r. Well, our r is -5, and if I multiply that by a negative, and then my theta minus pi. Well, negative times a -5, my original r, negative times my r, would be +5. And then -2 pi over 3 minus pi is -2 pi over 3 minus 3 pi over 3, which is -5 pi over 3. Checking our angle here. -5 pi over 3 is going clockwise around our unit circle, so -5 pi over 3 would go all the way to the first quadrant. It's not quite -6 pi over 3, which would be -2 pi. And then extending that all the way down here, so we're here. And then 5 out, it's positive, so we're going along that radial line. So I'm not going to move down here, I'm going to stay up on the radial line. And then it's 5 out in that direction, so 1, 2, 3, 4, 5. Same coordinate point. And then our last one here, -r, so negative times our r, theta plus pi. So again, my r was -5, so negative times that r, and then theta plus pi, which would give me +5, and then -2 pi over 3 plus pi, which is -2 pi over 3 plus 3 pi over 3, which is pi over 3. And again, checking our angle for the last one, pi over 3, same radial line here, positive, so we're moving along that radial line, 5 out, puts me at the same location. Okay? Okay, so again, if you're still sitting there going, that was a little rough, I think I might need to practice naming those, pause the video now, go over to the extra practice video, do some extra practice, come back when you're ready. Okay? Because the last thing we are going to look at here is converting between our rectangular coordinates and rectangular forms, which is the ones we are more accustomed to up until today, x, y's, and taking those and converting them into polar, r theta, or the reverse, taking r theta, polar coordinates, polar forms, and turning them back into rectangular, x, y. And you're going to be doing this same type of conversion idea within the following objectives of this unit. For today, for this objective, we're going to be looking just at coordinate points. Only those. Okay? So we have a reminder of our polar coordinates up top here. Polar, remember, is r theta. Rectangular is x, y. And then we have some relationships that we've looked at kind of over the course of our math career, even within this class, and that they are going to be ones that we will be using as we look at conversions. So first up, we have x squared plus y squared equals r squared. This, as a reminder, is the area formula, not area formula, I'm sorry, the formula for graphing a circle. So we would have done these back, I believe it was, I want to say it was unit 6. I could look that up though if anyone wanted to find them in their notes and couldn't. Send me an email. I'm more than happy to look at exactly what unit and objective that was. But we looked at graphing circles, so this is the formula for graphing a circle. Okay, we have cosine theta equals x over r, which we looked at initially speaking in unit 8, but then again in unit 9. Okay, or its slightly altered form, which is if we took this cosine theta, which equals x over r, and we multiplied both sides by r, so we multiplied the denominator over to the other side, we'd get x left over, because the r would have multiplied over to the other side, so x left over, and then on this side r cosine theta. A similar idea here with sine. Sine is y over r, remember? And then if I multiplied the r over to the sine side, I'd have my y left by itself now, and r sine theta. And then tangent theta reminder is y over x. Okay? Each of these relationships is used in a different way. A lot of times we use this top one. So say we use to find r given x and y. So you'll use this one, I'd say primarily when you have a rectangular form that you're trying to turn into polar, right? So we can take our x, y from our rectangular and turn it into r. Okay, our cosine and sine ones, I would say, are used primarily to find x and y. Used to find x and y given r and theta. So again, we'll use this primarily to take a polar coordinate and turn it into a rectangular one. And then this tangent theta, a lot of times I use this tangent theta one to find theta, because I can solve for theta, given x and y. So again, kind of summarizing it one more time, I use the top and bottom one when I'm trying to find my polar coordinate given a rectangular, and I use the middle two when I'm trying to find a rectangular given a polar. At least that's when I use them. All of them, though, are up for grabs so that you can identify or you can find, solve for whatever missing values you need within your conversions. Okay? So there are two types of conversions we're going to look at. 8, 9, and 10, we're taking polar coordinates and turning them into rectangular. Same thing, I'd watch one, at the most two, and then make sure you pause the video, give one or two of them a shot on your own. That way you figure out, am I actually understanding what's going on? And then go over and do the extra practice video if you need extra help. Okay? So, number 8, we have two things we're going to do for each of these. First is we're going to practice plotting the coordinate points in our coordinate system. Give us some extra practice there. And then B, we are going to now practice converting to rectangular coordinates. Okay? So A is up first. Plotting our point. Okay, this is a polar, so we have our r theta. Theta is pi over 2. If I were to graph that radial line, that would be here. And then extending it in the opposite direction. My r is positive, so I'm moving along my radial line, so I'm going to be up here somewhere. In this case, it's 2, so I'm moving 2 in that direction. 1, 2. It would be right there. Okay. And then B, convert to rectangular coordinates for the given point. Okay, so I've got an r and a theta, and I want an x and a y. And so again, that's usually where I use these middle two here, is if I have an r and a theta, I can solve for x and y pretty quick. Okay, so x, just as a reminder, is r cosine theta. Y is r sine theta. Okay, well, given that fact, I can solve for my x, y for this polar point. Okay. My x then would be my r, which is 2, times my cosine of theta, which is pi over 2, which is 2 times the cosine of pi over 2. Take a moment. What's the cosine of pi over 2 again? Draw your triangles, do your unit circle, do your hand trick, whatever. However it is, you figure out what cosine of pi over 2 is. And cosine of pi over 2 is 0. And so this is 2 times 0, which is 0. And then y equals my r, which is 2, sine of my theta, pi over 2, which is 2 times, what is the sine of pi over 2? Well, that's 1. And 2 times 1 is 2. And so my rectangular coordinate would be xy, 0, 2. And then you can always do kind of a quick spot check to make sure your conversion made sense. Take a moment and imagine if this was a rectangular plane instead of a polar plane. would 0, 2 roughly make sense for where you've plotted your coordinate point? And again, it'll be a little bit of an approximation in some instances, although this one's pretty perfect. But does it, roughly speaking, make sense? Does the quadrant even make sense? Right? Okay, in this case, 0, 2, where would 0, 2 be if you were to plot that xy coordinate? Well, x0, y2 would be right about there. Sure enough, it makes sense. Okay, number 9. Number 9, we have first up our graphing. So our theta, 3 pi over 4 is my theta here. Where would 3 pi over 4 be? Okay, well, that's the 45-degree angle in the second quadrant. Okay, -3, so we're moving away from that radial line. So I'm going to be down here on the dotted line, and we're moving 3 in that direction. So 1, 2, 3. Puts me right there. Okay, and then our conversion. So I'm not going to rewrite these xy relationships. We already have them written down. I'm just going to use them. So x is my r, so my -3. Cosine of my theta, 3 pi over 4. Okay, we'll go ahead and take a moment. What is the cosine of 3 pi over 4? Okay, well, 3 pi over 4, remember, is in the second quadrant. Cosine, therefore, would be negative. All students take calculus, so sine is positive in the second quadrant. So we have a negative number here. And it's the pi over 4 angle, so what's the cosine of pi over 4? That would be √2 over 2. And so my x is negative times a negative is a positive, 3 √2 over 2. Okay. Y then is my r, my -3, sine of theta, 3 pi over 4, which is -3 times. Take a moment. What's the sine of 3 pi over 4? Okay, again, second quadrant, sine is positive, and sine of pi over 4 is √2 over 2. So this would be -3 √2 over 2. So my xy coordinate is 3 √2 over 2, -3 √2 over 2. And again, I always recommend doing a quick double check. I have no idea what 3 √2 is, but you know, I roughly speaking know kind of ish where that would be. And if nothing else, I definitely know the direction. I can at least check my quadrant. Does my quadrant make sense? Because I know this ended up in the fourth quadrant of a rectangular system. Okay, well, my x here would be positive, y negative. Sure enough, this coordinate point would sit in the fourth quadrant. And so if nothing else, the quadrant makes sense. And again, if you wanted to get a little bit more exact with your approximation, you could approximate what √2 is and then multiply that by 3 and divide by 2. But again, if nothing else, check the quadrant. Make sure that it makes sense. Okay? Okay, last up, if you haven't already, pause the video, try one on your own. That way you're getting a gauge. Are you actually understanding what's happening? Okay, graphing my r theta here. Theta is -2 pi over 3, so we're going clockwise. -2 pi over 3 would be the 60-degree angle in the fourth quadrant. Our r is +4, so we're moving along that angle, 4 in that direction. Okay. And then for your conversion here, we have x equals my r, 4, cosine of my theta, -2 pi over 3, okay, which is 4 times, take a moment, what is the cosine of -2 pi over 3? Okay, well again, -2 pi over 3 is in the third quadrant, cosine therefore would be negative, tangent is positive in the third quadrant, so cosine is negative. Okay, and it's the pi over 3 angle in that third quadrant, and so the cosine would be 1/2. Y is my r times sine of theta. Okay, what is the sine of negative 2 pi over 3? Okay, well again, third quadrant, sine would be negative, pi over 3 angle, that would be root 3 over 2. So the 4 and the 2 would simplify to negative 2 root 3. So my xy coordinate is negative 2 root 3. And again, doesn't hurt to double check. Negative 2 would send me left, negative 2 root 3 would send me down in an xy coordinate, which would put me in this third quadrant. Okay, so again, pause the video if you need to. Go do some extra practice with converting to rectangular if you need to. But the last bit here of objective 1 is taking rectangular and converting them into polar coordinates. Okay, and so we're going to be doing three things here for each of our problems. We're going to start by plotting the point given in the rectangular coordinate system, just so we have a vision of kind of what we're looking at here. We're then going to convert to polar, and then we also are going to practice identifying some other names here. We're actually only going to be naming 2 for this one, although if you want to name all 3 when that's applicable, you can. But one of these coordinate points actually only has 2 other names within our negative 2 pi to 2 pi. So you'll only end up with 2 for one of these. But the other 2, you could name all 3 angles if you wanted to practice finding all 3. Okay, so same thing. Watch 1 or 2 of them. Pause the video. Give the next ones a shot on your own. Do some extra practice with the extra practice video if you need to. Okay, we have A, 4, 0, plotting our point. Okay, well 4, 0 is out here. B, converting. Okay, I've got an x, y coordinate point. So again, when I'm given x and y, I usually use these 2 to find r and then theta. Okay, so first up, let's go ahead and find our r. R, remember, is x squared plus y squared equals r squared. And so my x squared here, 4 squared is 16, plus my y squared, 0 squared is 0, is equal to my r squared, which means 16 plus 0 is 16, which means r is, technically speaking, positive or negative 4. Okay, and I'll explain why you want to consider that it could be positive or negative 4 in a bit here, but it could be positive or negative. My theta then, tangent theta, remember, is y over x. Okay, so my tangent theta is 0 divided by 4, which is just 0. And so then I know what theta is. Take a moment. What angle measures give me a tangent of 0? Okay, well, there are technically speaking, well, there are technically an infinite number of angles that give me a tangent of 0, but between negative 2 pi and 2 pi, there are 3 angle measures that give me a tangent of 0, right? Those 3 angle measures are technically speaking negative pi, 0, and pi. All 3 of those angles, when you do sine divided by cosine, you get 0. Tangent is 0. And so all 3 of those angles work, and this is the importance of recognizing that when you square root, it's plus n minus r, because depending on what angle measure you use, the r is going to change. We need to end up located here, right? That's where 4, 0, my rectangular point, lies. And so what type of angle is that? Well, if I used an angle of, let's go ahead and use the first one, an angle of negative pi, take a moment and picture, whoops, sorry, r theta. Theta should go second. Take a moment and picture where would that radial line therefore be? If I do the negative pi, where would that radial line be? Okay, well that radial line would be out here, right? With the dotted line going the other direction. That would be negative pi. Well, what kind of r would be needed to get me to land here in my coordinate plane? Well, I can't use positive 4. Positive 4 would send me along that radial line, right? 1, 2, 3, 4 in this direction. I need to use the negative 4 for this particular angle, because that's the only thing that would send me along the dotted line portion. Okay, but you have already found two other names, right? Because there are two other angles, 0 and pi. Okay, well if I did 0, picture what that radial line would be. Okay, well that radial line would be the reverse of what we have here. That radial line would be a solid line this direction, and a dotted line the reverse. That would be a 0 angle, is right there, right? And so to land on this line for a 0 angle, I keep putting my theta first, sorry. To land here for this angle, 0, I need to have a positive r to land on the line. If I use the -4 here, it'll send me away from that angle. So I want to use the positive to send me in that direction. So this would be +4. Okay? And then our last one is our pi. Picture that radial line. Again, pi, that would be like the red line, would end up here, dotted line the reverse direction. Okay, so to end up with this coordinate point, I would need a -r to send me away from that line. Okay. Okay, let's do another. Okay, let's start with plotting our coordinate point, 2, -2. Where does that sit? Okay, well, 2, -2 would be in the 4th quadrant. Okay. Coordinate point then, so x² plus y² equals r². My x is 2, so 2 squared is 4. Y², y is -2, -2 squared is 4. Okay, which that means that 8 is r², and so r, if I square root both sides, is plus and minus √8, or 2√2 if you prefer that. Rather than √8, you could say plus or minus 2√2. Okay. Theta then, tangent theta equals my y over my x, so -2/2, which is -1. And so then think a moment, what angles give me a tangent of -1? Okay, well, that would be the pi/4 angle, right? And it's the pi/4 angle in either the 4th or 2nd quadrant, because the pi/4 angle in the 1st and 3rd would have tangent be +1. Tangent is negative in the 2nd and 4th. And so my theta, and there are lots of ways you could name your theta here. You could name it as, well, 2nd quadrant would be 3 pi/4. 4th quadrant would be 7 pi/4, or you could name them as their negative angles as well, right? 7 pi/4, which is in the 4th quadrant here, is the same thing as -pi/4, right? If I subtracted 2 pi from that. And 3 pi/4 is the same thing as -5 pi/4. So you have a lot of potential angle names that you could use to get you to land here at this coordinate point in our 4th quadrant. Okay, and so pick whichever one you prefer. For me, I liked the 3 pi/4 myself. Oh, goodness, I keep putting the theta first. I apologize. R theta, remember theta always goes second. So I like the 3 pi/4 myself. Okay, and so where would 3 pi/4 be if I graphed that radial line? It would be in the 2nd quadrant here. Negative going the other way. Okay, and then to get me to land at this coordinate point, I would need my r to be a negative number, because if I had a positive number, I'd be going out along this radial line. Negative sends me the opposite direction. So I want to use the -2√2, or the -√8, whichever one you prefer to call it. Okay, and then we want 2 additional polar coordinate points. Well, you've got 3 to choose from. We've already used the 3 pi/4, so maybe we use the 7 pi/4 next. Okay, we'll think about where 7 pi over 4 would be as a radial line. 7 pi over 4 is in the fourth quadrant. And so its dotted would go the reverse way. And so what kind of r do you need now? Well, because 7 pi over 4 is already in the fourth quadrant, I want a positive r because that will move me out along this radial line. And so I want to use the positive root 8, or the positive 2 root 2, whichever one you're going to call it. Okay? And then either negative pi over 4 or negative 5 pi over 4, it's your choice. I'm going to do the negative pi over 4 one. Negative 5 pi over 4 has the same radial line as 7 pi over 4, so the blue line here. And so again, I want a positive r for that guy. If you did the 5 pi, or negative 5 pi over 4, negative 5 pi over 4 has the same radial line as 3 pi over 4, the red line. And so if you did negative 5 pi over 4, you'd have a negative radius, like the 3 pi over 4 did. Okay, so last one, pause the video if you haven't already, give it a shot on your own, restart it when you are ready. Okay, first up we have plotting our coordinate point. So I don't know exactly where negative root 3 would be, but it's less than negative root 4, so less than negative 2, but pretty close to negative root 4, and so we're going to be pretty close to negative 2, but a little bit less. And then y of 1, so up 1. So we're looking at kind of roughly speaking there. Okay, b, our conversion here, x squared plus y squared equals r squared. So my x squared, negative root 3 squared is 3. Y squared, 1 squared is 1, equals r squared. 3 plus 1 is 4. And so r is plus and minus 2. Okay. Tangent theta is y over x. Okay, so 1 over negative root 3. Or for those who are not comfortable seeing it this way, some people might look at that and know what their theta is, but the other thing you could do is rationalize the denominator. Let me zoom in on this a little bit. Okay, the other thing you could do is rationalize the denominator, multiply top and bottom by root 3, and you'd have negative root 3 over 3. If you're more comfortable finding theta with this ratio rather than this one, then you could rationalize the denominator. Okay, so what would your theta be? Okay, well, the angle that gives me a tangent of 1 over root 3 is pi over 6. And then I want this to be negative, so I want the pi over 6 angles for tangent to be in the second and fourth quadrant. So what pi over 6 angles lie in the second and fourth? Well, second would be 5 pi over 6. Or its corresponding negative angle, if I went the opposite direction, subtracting 2 pi from that, be negative 7 pi over 6. And then the fourth quadrant pi over 6 is 11 pi over 6. Or its negative, which would be negative pi over 6, subtracting 2 pi from that. Okay, and so coordinate point, first one, you can pick any of the thetas you want. When I did this one, I did the 5 pi over 6 first. And so 5 pi over 6, if I were to graph that radial line, is the 30-degree angle in that second quadrant, dotted in the other direction. And then do we want a positive or a negative r for this one? Okay, well that coordinate point lies on that radial line, so we want the positive r. If we use the negative r, it would move us away in the opposite direction along the dotted line. Okay, and then C, 2 other coordinate points. Again, you can use whichever ones you want. Since I already did the 5 pi over 6, I did the negative 7 pi over 6 next, because I realized that those are going to have the same radial line, So they would have, therefore, the same radius. Negative 7 pi over 6 also puts me in the third quadrant. And so I'd want a positive r. And then I did the negative pi over 6 next. Negative pi over 6 has a radial line in the fourth quadrant. So it would be this one here. The fourth quadrant, dotted in the other direction. And so in this one, I wouldn't want a positive r. A positive r would put me on this line in the fourth quadrant. I want a negative r, sending me in the opposite direction into the second quadrant. And so I want to use negative 2 for that one. Okay, and then if you also did 11 pi over 6, that's the same radial line as negative pi over 6, so 11 pi over 6 would also have an r of negative 2. Okay, so again, if you have need for any extra practice with any of the other problems or any of these ones we've done here, there's an extra practice video. Please feel free to make use of that. And then if you have additional questions or need additional practice with any of those concepts, reach out to your teacher. We're here to support you. Okay, that's objective 1.